Before I show you how the different kinds of search work with the MongoDB Atlas platform, let's look at the architecture I have laid out here. It's very basic. There is a imaginary product catalog of about 50 items, and that has been vectorized, and the embeddings are now sitting inside of the MongoDB Atlas clusters, within which there are different collections, and the one collection I'll show you in a moment here is for an e-commerce application. What's happening next is there's a Python application, we'll look at that in a moment, where a user, and I'll be the proxy for that user, will be entering questions and queries in a certain structure, and that's the goal of this part of our uh, learning here. And how that generates different kinds of response is what we'll see. If you're interested to think more about what this LLM is, which is offering this specific kind of vectorization capability, it's this guy here. It's Olama, and the specific LLM I'm using is GPTOSS 20 billion parameters. All that said, let's look at what's going on inside of the specific collection I was showing you. So Atlas is the platform within which there are projects. Within the project, there are clusters, and within clusters, there are collections. So the one I'm showing you now is this e-commerce demo in which I have a products folder. So those 50 products have been vectorized, as in all that information has been made available in this system. As you can see here, right? This is the vectorization that's available now. And those embeddings were generated, as I mentioned before, thanks to the LLM. So here's the full description for all of these products. It's almost 50 products in here, and they all have their own name, description, and things along those lines. Obviously, as and when information changes, there will be incremental updates at any point. Perhaps you can even refresh this and all of that. So that's what's going on here on the MongoDB Atlas side. Let's look at the search system. So like I said, there's a Python script which I have created with some help from Cloud Code, and you'll see very quickly the different options we have on search. So let's go through these organically, right? I can search for a specific keyword, so I need boots, for example. Only one item comes up. It's not very useful, to be honest, right? Because shoes, boots should be sort of the same, right? But the system doesn't know. If I'm throwing a keyword query at it and I'm explicitly saying it's a keyword specific query, give me the results, it's not failing me. It's doing the right thing by saying, you asked for boots, I'm going to give you boots. I'm not going to make an assumption that they are both similar things. So when it begins to veer in the direction of similarity, that's where we start to talk about the concept of semantics, a semantic search. And an example of that and how that comes to life here, and as you can see up here, there's different ways in which these queries are going to be structured. So search is my leading sort of command which helps me pull that query off. So I'm going to search in this case for, let's say, gift for dad who likes hiking. So let's see what we get. So here's a bunch of things, right? And now the idea is that because of this keyword, or rather I should say because of this specific command, the system knew that we need to run a semantic search. And it ran a semantic search, and it has produced a result which is semantically aligned with information we have on here. Uh, and I can keep pushing this, but let me still stick with sort of pure semantic search here. So I'm going to say search gift for dad who likes hiking for less than $50. So see what happens here. Now it's going to give me results, but you can see here it's not less than $50, right? So the semantic is not using the filters. So we saw here keyword search, we saw here semantic search, but we have not experienced a hybrid of these two, right? For which, and I'm going to pull up the help menu quickly to show you how this will go about, the keyword is filter, right? This keyword or command actually is coded to create that output, that outcome for me. So we're going to filter, but still use a semantic way of looking for it. So going back to again the same dad who loves hiking. So gift for dads who love hiking. And the way we're going to pass the request is to say price, and it's coded to say anything less than. And in fact, let's also go with a rating of say, I only want 4.5 and above on this. So there you go, right? No errors in the price or the ratings. So as you can see here, right, we've gone through three levels here. We looked at a keyword search, which is strictly tied to keyword. It's producing results which are an exact match. Semantics goes beyond. The hybrid of the two uh, looks something like this, right? Now, as you can imagine, right, we are looking at the very back end of how a system behaves in a real world e-commerce application. And another example of that is sort of similar items, right? And similar in this case is not tied to the product description. They are looking for product code, right? So depending on again, how the application is configured, the way for you to generate these results as a user navigates through the system, that is what you see in action right now. So as you can see here, right, the similar keyword is not configured to go beyond the product ID. So that's what it's doing. Of course, that logic can be expanded. So I want to stop this video here, but in the following up versions, I'll show you how this data itself will become more intelligent, or the systems wrapping it will become more intelligent and help us do a better job in a real world scenario. Thank you.